Okay, so we have chi-square goodness of fit going on right now. And what exactly is chi-square? So we went through the steps on Monday how to get this chi-squared value. And your chi-squared value is similar to a z-score or a t-score. It's measuring how extreme something is, okay? Chi-square specific, and then we make a decision, do we have significant data? So we get a z-score, a t-score, or a chi-square value. And we then make a decision by going to a table and say, do we have significant data now? Is there a significant difference? Do we have evidence to support that HA? Okay, so exactly what a chi-square statistic is it measures, it's a measure of how far the observed counts are from the expected counts. So get that down. And just like a z-score or a t-score, we do have a formula for it. It's on the board up here, but I'll put it up here and describe it because I have had a lot of absences lately. Here is the formula. Chi-square. Chi is a Greek letter. We don't say chi, it's chi. Chi-square is equal to sigma. Sigma means sum. And we take our O minus our E, we square it, and we divide by E. The biggest piece of advice I have for you is don't try to plug everything in at once. Take it a piece at a time. So take that O minus E. First, hit enter in your calculator. Then square it, hit enter, then divide by E. What does sigma mean? That means the sum. We'll practice it today. What does O mean? O is your observed counts, and that will always be given. And now E is up on the whiteboard as well, but I want to write it down again just to make sure that you have it because, like I said earlier, there's been a lot of absences. So E is your expected count, and you will find this. You have to do some sort of calculation to get this. Now, there's a formula for the expected count, and it's going to be one of two options. So you need to analyze that, and we chatted about that on Monday as well. When you are given a percent, it's going to be N times P. What is N? N's your total sample size, and P is your percent. And just remember that percent, you do need to make sure you put it in a decimal. Okay. I'll give people, if it's 10%, they'll take 500 times 10. No, 500 times 0.10. Now, if you're not given a percent, you will usually be given a keyword that says evenly distributed. Even if you're not given that evenly distributed, usually you can assume that it's evenly distributed, or just ask me, maybe the question's written wrong. When you see the word evenly distributed, the formula is N divided by the number of categories. So on Monday, we got as far as step 4, getting that chi-square statistic. And I think I had someone in this class actually say, well, what does that mean? And that's what we're going to talk about now. We're going to practice using that chart. So have this chart handy wherever you have it. We're going to get some practice with it. Anyone else need one? Okay, so Are we okay to move to the next page? Finding the p-value. You need two things. You need your degrees of freedom. The degrees of freedom are a little bit different than the t-distribution. You do not take the sample size. What you do is you take the number of categories you have. And then you subtract 1. You need two things. You need your number of categories, and you also need your chi-square value. And we're going to get some practice with it, but what you're going to do is you're going to look at your degrees of freedom, and you're going to find your chi-squared value in that row, and then you're going to see what is the tail probability, or what tail probability is it in between. So you're probably thinking right now, what exactly do I need? The main thing you need to get from this slide is, in order to find your p-value, the two things you need right now are the degrees of freedom and the chi-squared value. So the chi-squared value comes from step 4, and the degrees of freedom you find. Does everyone understand at least that? In order to find the p-value, two things. Okay, so moving on. Well, how do I find, what do I mean by that step number 2? Okay, we're going to practice the chi-square chart right now, just finding the p-value. And then we'll quickly kind of cruise through that yellow problem, and you should get some work time. Remember, tomorrow will be a work day, and then Friday will be a short Schoology quiz, so you'll have time to get some stuff done as well. Mr. Jans and I really are trying to set it up so things can get done in class, just because the end of the year, and I know you guys have a lot going on. Okay, so what is the p-value for? If you have a degrees of freedom of 5 and a chi-square value of 7.99, we have our two things that we need in order to find the p-value. So I'm going to go to my chart right now. I'll give you a second. Degrees of freedom of 5. So I'm going to highlight degrees of freedom of 5. What was my chi-square value? 7.99, right? Okay, so you want to see, okay, for degrees of freedom of 5, I have 6.63. My chi-square value is bigger than 6.63, so keep moving. 7.29. My chi-square value is bigger than 7.29. 8.12. My chi-square value is not greater than 8.12. So my chi-square value falls in right here, right? My chi-square value is between 7.29 and 8.12. Now what I need to do then is I need to go up to the tail probabilities. What that means is our p-value is between 0.20 and 0.15. Okay, our p-value is between 0.20 and 0.15. So we won't know our exact p-value. When you get to college, you will. But right now in Intro to Stats, you just know that the p-value is somewhere between 0.20 and 0.15. So that's all we write down. Let's try, I have 3 of them. Let's try this one on your own. Maybe I only have 2. I do. Okay. Degrees of freedom of 10 and chi-squared value of 22.8. I'll walk around while you guys are trying to find it at this time, and then if you have questions, let me know. Doesn't matter. I would prefer you go be serious, but I won't. I don't need any help. Okay, what did we get our p-value in between? Okay, so the p-value is between 0.01 and 0.02. All right. Now this last one is a little tricky, okay? And that's why I wanted to do one more. Does anyone need me to do this one on the board? It's okay to say yes. Okay. This last one's a little tricky. Try this one. Degrees of freedom 2, chi-square 1.29. Okay, so some of you guys are noticing already while I'm walking around. So let me go to the chart. If I go to degrees of freedom of 2. No, it's possible, okay? Degrees of freedom is 2. Right away you see that you have 2.77. Where does our chi-square fall? Yeah, it falls right here, right? Okay, so we know that our chi-square value has to be what compared to 0.25? It's got to be before it, right? Because, no, you don't say 0. You just say that our p-value, right? Our p-value is what compared to 0.25? It's greater than. How do you know that it's greater than? Yeah, from when you're moving this way, the p-values are getting bigger, okay? The p-values are getting bigger. So we would say our p-value is greater than 0.25. So let's write that down, and then I'm not gonna give you another one, but I want to talk about one more. All right, let me just see if you really have it. Let's say the degrees of freedom are 7 and my p-value was 27. So if I go to 7, I'm going to underline the row. Did I say p-value? I meant chi-square value. Okay? So let's say the degrees of freedom are 7 and the chi-square value is 27. So you see we go off the chart. What would you say your p-value is? Yeah, our p-value is less than 0.0005. Very good. Okay, now that we have that, we can draw a conclusion. So let's practice that, this number one quickly. I'm gonna kind of cruise through the first 4 steps because we've done it before. And then we'll finish up step 5 and step 6, which is new. So step 5 is finding the p-value. Step 6 is drawing the conclusion. After that, it's time to work. I've said it already again, not everyone listens. Work day tomorrow. I may give you something new to practice, so I'll just beware. And then Friday will be a quiz. Are births evenly distributed across the days of the week? The one-way table below shows the distribution of births across the days of the week in a random sample of 140 births. Right away, that 140 is your N. Evenly distributed should kind of key you in that I'm going to have to use N divided by the number of categories to get that expected counts in step 3. But step 1 is to make a table. And well, I already am given a table, so I don't need to make that table. Step 2, so if you were gone on Monday, we got through the first 4 steps, okay? Step 2 is your hypotheses. Now your H nut is always a statement of something being the same. Or it's an is statement. So it is the same, okay? The distribution of local births are equally likely all days of the week. Where did I get that phrase? Okay, I got that phrase here. Does the data give significant evidence that local births are not equally likely all days of the week? Use your question to help you write the alternative and the null hypotheses. Okay? The question will always give you a hint of where to go. So because the question is talking about not, that's my alternative hypotheses. The distributions of local births are not equally likely all days of the week. If I know my alternative, I know that it's just the opposite for the null, or vice versa. Are there questions there? People struggle with that sometimes, so make sure that you let me know during work time. I did not put the key for the null and the alternative because it's too tempting just to copy it. So just let me know, I'll let you know if you did it right. Step 3 is to find the expected counts. The expected counts you want just right under the table, okay? In this case, because it's equally likely, I need to take the number of categories. I need to take the sample size first, which is 140, divided by the number of categories. Yeah, question? Yep, so in each not is always like an is statement, or it's a question, or it's a statement about two distributions being the same. One or the other. And there's question number 4, it's about being the same in your homework. And then HA is always a not statement, or it's a statement about two distributions not being the same, different. Okay? Back to the expected, I'm going to take 140 because that's my sample size. I'm going to divide by the number of categories. I'm dealing with the days of the week. How many days a week are there? 7. So it's going to be what? 20. What should happen if they're equally distributed? I should have 20 births a day. Okay? I'm going to write that up here. You'll notice on the whiteboard over here, if you were gone on Monday, this one we had percentages to find that expected count. So we did N times P. This one is different. Okay, so I just wanted to expose you to both. Are we okay on the expected? The tedious stuff now. The chi-square. Okay, this is the one that you won't like the most because it just takes a long time to calculate. And know that when you get to college and take statistics, your calculator will do it for you. But for now, we do need to show our work. I take my first observed value, which is Sunday. Okay, what did we observe on Sunday? Yeah, we observed that it was 13 births. There should have been 20. So I'm taking my formula now that's on the whiteboard, and I'm saying my first observation minus my expected. I square it, I divide by my expected. I do it again. Tuesday, 23. I'm sorry, why did I say Tuesday? Monday. 23 is the observed, the expected is 20. Tuesday, the observed is 24 minus 20 squared divided by 20. Sunday, Monday, Tuesday, Wednesday, 20 minus 20 squared divided by 20. Thursday, 27 minus 20 squared divided by 20. Friday, 18 minus 20 squared divided by 20. And then Saturday, right? 15 minus 20 divided by 20. So I don't have to calculate this all out. Can I get some help? So who's got their calculators on their desk right now that can help me? Kendra, could you do the first two for me? Lainey, could you do the last two for me? Marissa, do you have your calculator out? You just, I don't know why. Can you get it out and do these two for me? And then Megan, can you do this one for me right here? Okay. Or Janai or someone help me out, double check them. Just a friendly piece of advice when you're calculating this, like I said, take it a piece at a time. So O minus E, hit enter. Square, hit enter. Divide by the expected, hit enter. Kendra, do you have yours?
Yeah.
Okay. Is it you had the first two?
Yeah, the first one I got 2.45.
2.45?
Yeah, and the last one I got 0.45.
Okay, this one right here, which one
Yeah.
did you do? The second one?
Yeah.
Okay, and you got what?
0.45.
Okay. So who had the third and fourth one? Okay. How about the last one? Did anyone get those yet?
I don't know, 18 minutes, well, for that one is 0.20.
0.20?
Yep, and 1.25.
1.25?
I got 1.45.
For which one? This third one?
No, it's like adding those together.
Oh, okay, thank you. How about this one? Megan, did you get that?
2.45.
2.45?
So for the third one, I got
0.8?
0.8.
That's fine.
Yeah, and then for the second one I got 0.
0, which is right. Okay. So let's add those up right now in your calculators. People have your calculators out. 2.45 plus 0.45 plus 0.8 plus 2.45 plus 0.2 plus 1.25.
Six.
6.6, did anyone else get 6.6? 7.6? Perfect, thank you guys. Very good, no, I appreciate it all. Okay, our chi-squared 7.6, so that's the most tedious part. Once you're over that, it's kind of all downhill. We need to get our p-value. Remember with your p-value, you need your degrees of freedom and your chi-squared. So let's practice that again. What is our degrees of freedom? Number of categories minus 1. So our degrees of freedom are 6. Okay, go to your chart right now, find where your p-value is in between. Degrees of freedom are 6. 6.6 did we say?
7.6.
Or 7.6, okay. 7.6, so I'm right here, right? So what is our p-value?
Greater than.
Yeah, greater than 0.25. And now we just have to do our conclusion. And I rewrote this. Lots of you have this in your notes already, but if you needed it, that's your final step, your conclusion. If your p-value is less than alpha, what is our alpha usually always? 0.05, okay? We reject H naught. We have evidence for HA. If our p-value is greater than alpha, we fail to reject. Write that. You only need to write that down if you don't remember it, so I'll give you a few seconds to do that. We wrote that down when we first learned significance tests. So if you don't know where it is in your notes or you just want it down again, just quickly write that down again. So it's going to be one of those two options. All right, so we just have to write our conclusion, and I have our conclusion up here. We don't know what our p-value is, but we know that it's pretty high. It's above 0.25. So we take our conclusion and we then say, okay, we need to fail to reject H naught. So because our p-value is greater than alpha, we fail to reject H naught. We have no evidence for the distribution of births being not equally likely across the days of the week. So we have no evidence for that.